Welcome back to PTV Talks. It's good to be back. Today we'll be discussing urban street design concepts. And as always, we have Bill Cisco in the wings, and he'll be answering your questions in the chat. And he'll also be monitoring the Q&A session that we'll have at the end of this presentation. And then we'll have Liz popping in, delivering the polls, 3 poll questions that we have, and she'll be showing the results of these polls. And then, of course, I'll be taking you through the presentation today. This session's goal is to highlight a bunch of real-life urban street elements that you may encounter within your projects if you do that kind of work. And we'll show you how to model this in PTV Vistro. Today's agenda is pretty full, so I'm going to go through some of these topics quite quickly. But we'll start with a complete streets example, and I'll have a 4 to 3 lane road diet, and I'll show you how you can do that. And then we'll focus on inputs for the HCM 6th edition bicycle analysis. We haven't really paid too much attention to that in the previous session, so we're going to spend some time there today. And then we'll quickly show how to use the optimization routes for a one-way to two-way conversion project. And we have an example file within our install, and we'll be using that file. And then finally, we'll get into the highlight of the day, the tour of the city of Boulder's Pearl Street Pedestrian Mall. And we'll highlight a bunch of urban street concepts that are all working together within this, this small area of Boulder. So first, let's jump into the complete street use cases. Sometimes you just want to do like a quick analysis to test operations along a corridor for complete streets. And PTV Vistro is a perfect tool for this because we have scenario management and mitigations, and you can test a lot within a complete street environment. Also, many complete street designs have bicycle lanes or even shared lanes and sharrows. And with Vistro, you have also the HCM 6th edition analysis where you can test bicycle inputs and impacts to vehicular traffic, as well as get bicycle delay and the level of service. So let's talk about the bicycle inputs in this first part with the complete streets. The first step when you want to do a bicycle analysis with the HCM 6th edition is that you have to create a signalized intersection. HCM doesn't apply to the unsignalized intersections with the bicycle methods. So you do have to have a signalized intersection, and then you have to make sure that you set the signalized intersection to the HCM 6th edition analysis type, which you can access that in all 3 of those first workflows that you have. And then step 3, you would enter the geometry inputs in the intersection setup workflow. And I've kind of highlighted this in the table. If you search for the Vistro online help and you look for the term signalized intersections setup, it'll pull up this table. And if you scroll down a little bit, you'll be able to see the meaning of all of these inputs that are related to bicycles. And I'll go over this in a little bit of detail on the example. And then finally, for step 4, don't forget to enter your bicycle volume. That's on the volumes workflow all the way down at the bottom. There's a row for bicycle volumes. And that's per approach going through across the streets. And so this is a pretty typical city setup where you may have like a 4-lane, 10-foot per lane roadway. So that gives you about 40 feet of space. And then you want to do a road diet of some sort down to a 3-lane case and squeeze in about 5-foot bicycle lanes on either side. And that gives you about 40 feet there as well. So on the before case, since you don't have a bicycle lane, the width that you would put for the parameter for the geometry input would be 0. And then also on the after case, since you do have a bicycle lane, then you can put 5 feet down for the width of that bicycle lane. In this example, we're assuming we don't have any outside shoulders, but if you did have an outside shoulder within your configuration, you can say that the reason for this input with outside shoulder is that's probably most likely where the bicyclist would be riding if it was large enough, or at least they would feel more comfortable. And then there's an option for curb. And so if you have a curb on your cross section, you would want to check this. Again, this impacts this comfortable level of the bicycle, either he or she is riding along a curb or not along a curb. And then as well, there's two inputs for parking. One is to identify the width of the parking lane, and then the other is to identify how much of that parking is being utilized. Again, if it's not utilized, this is creating extra space for the bicyclist to ride in. If it is heavily utilized and quite narrow, that could create some dangerous situations. And so all of this is impacted within the HCM calculation. So we have an example right here where we're showing this 4-lane roadway that's 10 feet. This is pretty close to where I used to live in Cincinnati. So I'm kind of familiar with this part of town. So if you did a road diet on this particular street using PTV Vistro, you have some advantages by using the scenario management. And by using this scenario management, you can easily retime the signals at the intersections and then be able to compare back and forth from one scenario and the other scenario, the different vehicles and bicycle LOSs and measures of effectiveness. So let's go ahead and jump straight into this example file. So I'm going to pull it up right now. And so in this example, we see our street. And if I zoom in a little bit closer here, yep, we can see that we have 4 lanes on the Vistro network, and we have a bunch of, in this case, 2-way stop control intersections. So again, let's go down to the signal, and then I'll show you where we entered the bike parameters. So if I click on the signalized intersection, I'm at the intersection setup tab. And if I scroll down to about halfway, this is where the bike parameters are starting. Let me highlight, these right here. These are what I showed on the previous slide. So we have that curb to curb width of the cross street. That's basically going from one side of the street to the other side of the street. How far does that bicyclist have to travel? And then we have the bicycle lane widths and those parameters that I mentioned. And then on the volumes tab, like I was saying, if you go all the way down to the bottom, we have some bicycle volume inputs where you can put how many cyclists per hour. And then on the traffic control tab, if you scroll pretty much down to the bottom again, there's the other modes of transportation. And so this gives you what the pedestrian level of service is, as well as the bicycle level of service and intersection scores. And you can see within this unmitigated road, what's the best way to say it? And without the road diet, we have a level service C, and we have a intersection score of about 3s. And then the bicycle delay is 12 and 7. So within this example, it's not bad. It's actually working okay. Of course, I have a low volume that I put in, but it's not bad for bikes. But if we go ahead and pull up our road diet scenario that we have, and I'll go ahead and click this. I already prepped this. You can see that now we have 3 lanes in here. And again, if I click on the intersection and look at the intersection setup tab, now we have a smaller curb to curb width because our streets are a little bit smaller. We do have the 5-foot bicycle lanes in there, and that's pretty much the difference there. And then if I look at the traffic control tab here, and scroll down to the bottom, we have a bicycle level of service of B, which is better. But the funny thing is actually the bicycle delay is slightly higher on one of the approaches. So it just shows you that, delay is the thing that you go to for vehicle analysis, but when you're looking at bicycle delay, that's not all of the story. It's also looking at this this score for the intersection, and that's more of like that comfort score. And since we have bike lanes and this bike facility, it's taking that into account with the level of service. So that's something to remember when you're looking at these results for bicycles. Okay, so let's look at the vehicular level of service. Of course, we have our graphic parameters on the side, on the left side. If you click on that, you can see that we're not operating great with the through capacity because everything is now smashed into one lane for the road diet. And if we go back to the existing, you can see that it was operating a little bit better on the through movements because we have the more capacity, more or less, for the through movement. Again, you would have to weigh the pros and cons with this. You have better bike operations and safety versus the vehicle operations and safety, so you would have to make the call if that's an appropriate road diet for you. And then if you look at the two-way stop control, again, this isn't going to take into account the bike traffic per se, but it will let you look at the vehicular traffic in a little bit more detail. So I'm going to pull up the delay numbers here. So we're looking at this left turn. There's a lot of delay as this left turn vehicle would be trying to turn left here. And if I go back to the road diet condition, we would expect it actually to be a little bit worse because now it's about 10 seconds worse because all of those through vehicles are now put into one lane. So, there's less gaps and possibilities for that left turn to pull out. So again, that's a way you can measure to see if this road diet would work for you. And if it doesn't work for you, then maybe you can do another scenario or another mitigation to determine what things you might want to do to improve this road diet. So I want to show you quickly how easy it is in Vistro to take a 4-lane section and bring it down to a 3-lane section. So I have this working scenario so I don't mess up my existing one. And I'm going to go over to the first 2 intersections here on the left side. And I'll go a little bit slower, I think, so it catches up. Yep. So what I'm going to do is take this 4-lane roadway and take it down to a 3-lane roadway. So it's really easy to go into our intersection setup tab. And then we look for our approach arrow to tell us what direction we're going. So we're going to change this leg. So it's this arrow. And all I need to do is just subtract this through. And I'm going to then, subtract this shared left through. And then I'm going to add a left turn lane. And then I hit OK. And you can see that it's added the left turn lane in the through. And then on the other side, I'm going to do something similar, but this time I'm just getting rid of the through and leaving the shared through right. And I want to add a median here to kind of match the turn lane on the other side. So I go ahead and check the median box, and then I'll add a median width of 10 feet. And you can say I'm adding a median. Now we still have this outbound leg with the 2 lanes, and this was a change that happened around Vistro, I believe it was 2020. If we click on this outside node handle and right click to open the context menu, all we have to do is click remove through lane, and you can get rid of that extra lane right there. So it's a quick way to do that. And then the other thing is now we have to go to this next intersection, and this exit pocket was added automatically because we still have 2 lanes here. But if I go to this next intersection and then we remove the shared lane and add a left. And then on the eastbound side, I go ahead and remove the through, and it already has the turnpike or the median from the adjacent intersection. There we go. And now I can remove this exit pocket by finding which leg it's on, and it's actually on the eastbound leg here. And we can see that there's one exit pocket, and I can go ahead and just delete that out, and it removes that exit pocket. And so that's what I would do all the way down the roadway. And you can see it's pretty quick to take that 4-lane roadway and convert it down to a 3-lane section for the road diet. All right, so now we're going to move on to our next example, which is the one-way to two-way conversion example that is actually included within the Vistro install. If you have the demo or if you have it installed, you'll have access to this. So if you're not familiar with a one-way to two-way conversion, NACDO has some resources that kind of explain these concepts and give some examples of where they've been implemented across the United States. But essentially, this can be used to transition from a central business district to maybe a more traditional neighborhood and provide that typical feeling of the two-way streets with parking on both sides. However, this conversion going from the one-way to the two-way section requires some turns that may be optimized as you navigate from the one-way pair or from the two-way to the one-way pair going in the opposite direction. So you always have to be conscious of that. How do you navigate and how do you optimize these turns to make sure you're having the best flow through these conversions? And so with Vistro, we can show this pretty easily. Again, with this example, we have, you can see that we have this optimization route coming down. This was kind of like you were here in the last picture where that dot is. So you were looking towards this one-way section in the central business district. But what we'd want to do is turn right from the where we were looking at before, and then turn left onto this Race Street intersection, which would then be that one-way couple going southbound. And so that's the route that vehicle would have to navigate through here. And so quickly, let me show you what this would look like within the example file. And since you have this example with the documentation, I'm going to go a little quickly here. So again, we have this is the two-way roadway, and we're going to turn down to the one-way couple down going south. And by doing this, you can just draw some optimization routes here. And here's the one I drew for that one-way couple. And this is showing you the time-space diagram of this turn combination. And it actually shows the green of this right turn with the green of the left turn. And that basically means that this turn is going to be able to kind of simultaneously go through the two intersections without having to stop and clutter up the turn lanes, which is what we want in this case. So it just shows the power of the Vistro optimizations along the routes and how they can be used for this one-way couple. And we'll see this a little bit more in the Boulder example that we have coming up. Okay. Which is now, we're at the Boulder example. So let's go into, let's tour the city of Boulder's Pearl Street Pedestrian Mall. This is what's kind of in that pinkish colored brick pavement. That's the Pedestrian Mall in Boulder. And it actually runs more or less east-west, straight into the mountains. You can kind of see that. We have some videos and we have an interactive Google Earth tour on LinkedIn. You may have seen that already. And we also have a knowledge base article that combines both the video and the Google Earth tour plus a description written. So that's probably your best source if you're interested in what we want to show you. And you can go ahead and scan this QR code to kind of get that access to that knowledge base site. This section around Pearl Street, I mean, it has a lot of urban street applications to connect up to this pedestrian area, which hopefully you'll see on this next slide. Here's an overview of the Vistro model that I created. Yeah, the gap in the middle, basically where all those exclusive pedestrian phases are, that's the Pearl Street Mall. And on 4 corners of that mall, they have the 2-way to 1-way conversion intersections to kind of route people around that pedestrian mall in like a 1-way circulation. And so that's how they dealt with kind of closing down a street and routing traffic around that. But how do you first plan a pedestrian mall? That's a good question. Like, how do you know this pedestrian mall and then the parallel networks next to the pedestrian mall? How do you know that's going to work? Or like, how would you close a street down for it? You know, maybe construction, or if you have an event or something like that, like a block fest that closes the street down for a weekend. How do you know that's going to work, and how do you know the plan that you are recommending will work? Well, we can kind of test this out within Vistro using the trip generations that we have. You can use the add and remove trip generation data, and then this will kind of do this detour analysis for you. Oops, hold on, Liz, that's not a poll. I went too far. So I'm going to pull up the Boulder example that I have, and we have a scenario called detour closure. And if I zoom out just a little bit, and I'm going to actually shrink the workflow menu, you can see that we have 4 zones. We have zones 1, 2, 3, and 4. Why we have multiple zones there is because one is actually a remove zone and one is an add zone. And if we pull out the trip generation workflow, which is right here, you can see that zones 1 and zone 2 on the other side are labeled as remove, and they're going to remove 200 vehicles. And zones 3 and 4 are labeled as add, and they're going to add back the 200 vehicles to the network. And when you look at the trip assignment tabs for this example, which is right here, the trip assignment workflow, the zones 1 to 2 here, which is that straight line that went down Pearl Street, this is actually giving you a negative volume. So it's subtracting 200 vehicles at every intersection traversing from west to east in this case. And the other direction from 2 to 1 is subtracting 200 vehicles from east to west. Now, where the add data comes in from the trip generation is with these 2 detour routes. Here we can add the data back to the network. So we're adding 200 vehicles now along this detour route. And then again, a detour route in the other direction. So this could be a way how you would test, you know, would a closure of Pearl Street for a pedestrian mall be successful? Again, this is an example, this isn't perfect, but this illustrates the point that this could be a way to test the pedestrian mall. Or if you have an event closure in your city, you can test this. So how do we know this works? So if we zoom in to one of the intersections, let's pick this one right here. We have on our base input volumes, you can see that we have the 200 vehicles going straight. But then again, if I go to the net site trips and click on that, we can see now the throughs are negative 200, but the right is now having a positive 200 added to that. So then when you look at your total analysis volume, I can click on the total analysis volume. Now I have 0 going through and now 250 turning right. So Vistro is adding those those routes, not routes, those paths, the trip assignment paths to every intersection within the network. And that's going to save you a lot of time, but it will also allow you to optimize these signals with the new traffic and see if the capacity can handle the additional traffic on those detour routes. Okay, so of course, though, you know, some caveats. I only showed one street here with the detour impacts. You may want to do the same thing on some of these other major streets that could have signed detours or something like that. So that could give you a little bit better result if you had more influences on what is impacting the detour and the closure. The other thing too is if you have some origin destination data, maybe you have, you know, some old studies, or you can pull something from some traffic model. The origin destination data will kind of help you say, okay, really what the traffic volume is going from one side of the city to the other, instead of just guessing. But that could be some good intelligence there. All right, so the next thing that we have here is we're going to take a look at the exclusive pedestrian phases. Again, Boulder has a lot of these exclusive pedestrian phases along the mall, so they can connect one side up to the other side. This is pretty easy, again, to do within Vistro and is part of the HCM calculation. So I'm going to pull up the example for, I'm going to pull up the example for this. Okay, this is the Boulder example, and then I'm going to show the exclusive pedestrian phase. Okay. So let's go to this big one right here in the middle. Okay, so we can see that we have the pedestrian mall on both sides of this, and basically all we need to do is just add that exclusive pedestrian phase to the signal controller just to represent the pedestrians crossing from one side of the mall to the other side of the mall. So if you go to the traffic control workflow, first, of course, you need a signalized intersection. So we just make sure we have a signalized intersection. And then within PTV Vistro, you have this exclusive pedestrian phase box already in the workflow. And so you can just type in a phase number, any phase number would work, but type in a phase number for this crossing for this exclusive pedestrian phase, and then enter some details such as the pedestrian walk time, which is everybody knows that's green, I guess, in Germany. And then we have the pedestrian clearance time, which is the don't walk or the flashing don't walk. And after you do that, then you add it to the sequence. You have to add it to the sequence. It's not going to be an automatic process. So you come down to the sequence, and then you would just select the phase that you put into the exclusive pedestrian phase. And then that will automatically add that to the sequence diagram the phase diagram down at the bottom. Now, don't get confused, because once you add an exclusive pedestrian phase to this, your traditional pedestrian bars will disappear, because in Vistro we have like the pedestrian bars for the traditional crossings. Those will disappear, and you'll get a bar that kind of looks like a vehicle bar. So just be careful. That is your exclusive pedestrian phase. That's not for vehicles. And then also, this isn't part of the HCM methodology, but if you wanted to estimate the combination of an exclusive pedestrian phase with traditional pedestrian phases, you have to get a little creative, but not too creative. So in that case, what you would actually do is not put the data in this exclusive pedestrian phase box. You would actually go up to the signal groups, and I'll do this really fast. Well, actually, I can't do it here. I'll go up to the signal groups and just add a new phase, and I'll show you how to put in a hold phase. So we'll go to the plus and say add signal group. let's just make up a number. We'll call it 40. And then I want to say that the green is 9 seconds. And then the yellow, which would be the clearance, I'm going to say is 16 seconds. And I won't have an all red. And I'll hit OK. And that created a phase 40. So did I hit OK? I didn't hit OK. Sorry. Maybe we have to have 1 second for red. I'll just do that for now. Hit OK. All right, so that's not working for me. So instead of trying to figure that out, it's probably because I already have this exclusive pedestrian phase in there. I'll just skip that part. But it does work that you can create a hold phase and then you can add it to the sequence. And then you'll be able to have the traditional pedestrian phases to go along with that. Okay. So that's the exclusive pedestrian phase part of the presentation. So if we go back to the PowerPoint here. I've talked a lot about the proposed leading pedestrian intervals, and I, again, won't go into this into a lot of detail because there isn't an example file actually in Boulder along this pedestrian mall that we have in the example folder. And the location of this example file is not really a leading pedestrian interval. It's actually an exclusive pedestrian phase. But I thought it would be a good place to add a leading pedestrian interval because of the mall, and it just was a good place for an example. But within the leading pedestrian interval, you can simply just add time to this delay vehicle green input. And what that's going to do is add this red block kind of in front of the vehicle green, which will cause the pedestrian bar to lead. And that's what the pedestrian bars look like. Again, the exclusive pedestrian phase gets rid of these pedestrian bars. But that's how you see that this leading pedestrian interval is working, is because you can see that the pedestrians would go first and then the vehicles go second based off of that red block. Now, note that this delay vehicle green is always going to be called. It's not actuated. So just keep that in mind. If you have a push button at your location and you want to use this, it's going to call that leading pedestrian interval every time. So that's just something to be aware of. Currently, there's not an HCM method for that. So that's the best we could do right now. Okay, so the next thing we're going to talk about is transit stops. And I'm going to go through the transit stops again pretty quickly because I want to get to the cycle track thing again. So with the transit stops, again, we have a great knowledge base article on transit stops and how to go through the different methods that we have. So please scan this and get to this knowledge base article to find out more about transit stops. But around the Pearl Street Mall, there's a lot of buses and a lot of connectivity, bringing pedestrians and to the pedestrian mall by bus. It's a good way to do it. There's a lot of nightlife and things like that. So it's just a safer way maybe to get home. But within Vistro, HCM calculations can represent the bus maneuvers that you can experience at a signalized intersection. But if you want to dive in maybe a little bit deeper into the impacts of a bus stop, the Canadian Capacity Guide analysis has both far and near side stop configurations. And what you can actually do is enter the information in the Canadian Capacity Guide analysis that says, you know, like how close this far side stop is to the intersection or how far after the intersection it is. And then that would then calculate some turbulence around the signalized intersection. And in Vistro, it's really easy to switch from one analysis method to the other. It's just a click with the drop-down arrow, and you can go in and out. We even have like the multi edit, where you can go in and change all of your intersections all at one time to the Canadian Capacity Guide, and then go back to HCM. So there's really no reason not to take a look at, or at least a peek at, what the other analysis is doing, and it could give you some information about, hey, maybe this bus stop here at this part of the intersection isn't a good idea. Maybe we need to move it somewhere else. Also, we have the estimates of active and passive signals, and we explain this in the knowledge base article. So if you had like detection for a bus lane, there's a way to kind of estimate that impact. And then if you have a passive signal, which basically is like a bus phase that is called like every cycle, that's pretty easy to do with that hold phase that we were talking about before. You can also use that for transit. And of course, take advantage of the Visum and Visum connectivity from Vistro. If you go into Visum, for instance, you can add your bus routes to the model quite quickly if you already have that geometry in place. Okay, so this takes us to cycle tracks, and I'm actually pretty excited about this. I want to spend some extra time on this because we have a new modeling technique for cycle tracks, and hopefully you'll appreciate that this modeling technique is a lot easier than the last modeling technique that we've presented. Vistro, as we talked about in the complete streets example, Vistro represents bicycles within the HCM calculation. But you can also visualize the optimization routes that are on a bike lane or a cycle track within the time-space diagram. But that actually requires you to have a physical object in the model for your bicycle track. And so I'll show you how to create that. Yeah, so this new technique, like I said, is much easier. And what I need to do is actually update a lot of the information that we have on the knowledge bases with this technique I'm going to show you right now. Okay, this is just a real quick highlight of what I'm going to show you. So how it works is we'll take like a whole bunch of one-way legs. Those are these like little sub-nodes, so to speak, that you can see at the quadrants of this intersection. And then we have the one main node, the master node, in the middle of the intersection. This master node is actually where you would code all of your bicycle inputs for the HCM analysis. And then the subnodes, that's where you could put all of your bicycle phase information. And then you tie all of those together onto one controller. It sounds complicated, but it's not. It's actually quite easy to do. And it's very fast because you don't have to worry about, before we had legs popping off the main node and trying to figure out like which lane configuration actually goes from one to the other. So this is much cleaner, and you can see in the Visum result below that it yields a pretty good result for your bicycle lanes. So let's show an example of this. And so I just have a real schematic based example here to kind of show the process. So if I zoom in, here's my main node in the middle, and these are all like little one-way streets that I have that I coded as bicycle lanes. And you just drag them on top of the existing intersection, and that's it. I mean, it's so much quicker. But in the main node here, if I click on that and go to the intersection setup, again, you can see that I have the bicycle information required for the HCM6 calculation all entered. And so I will get a great bicycle analysis from that. And then I have the bicycle volume at this intersection in the main node as well. These subnodes that are on the quadrants, the only thing I need to do there is just put in a different speed. So for example, the bicycle lane's not going 35 miles per hour, 25 miles per hour, it's going 12. So I can change the speed to 12, and that influences the time-space diagram, obviously. I don't have to worry about the volumes. I just have to put in the phase numbers. So within this one, since the main street was phase 8, I decided that this bicycle track was signal group 80. And then I can add signal group 80 to the sequence. And you can see that on each of these quadrants, as I click around, the phase diagram will highlight which phases are active at the intersections. So it's really easy to see which one is included at which cycle track here. And if I click on the main node, you can see that these are the vehicle phases. Okay, so to tie these intersections together, again, you just plop them down, and then you go to the controller ID, and you just select the same one as the main node, and then you're tied to the main node. So pretty quick. And then once you have the stuff copied, you can then reuse it for the adjacent intersection down the line. And that's actually what I did down here, and I was going to show you how to put it all together. But real quick, let's show the time-space diagrams for this. So 1 and 3 are actually the vehicle eastbound, westbound, and 2 and 4 are the bicycle eastbound and westbound. But as I click between 1 and 2 here, notice the change in the slope of your time-space diagram. And that is solely due to the speed of the bicycle. And I may not have changed the speed at this one. I'm just curious. Oops, hold on. This one may still be at, no, it's still at 12. Okay. So you can see that the slope is different. Now, what this shows you, though, is that the vehicle is having has a great green band, but the bicycle is, it's getting most of it, but there's some people on the end of the green that they're going to get caught at the next signal. And actually, it's worse than the westbound direction. The vehicle green band isn't bad, but the bicycle green band is pretty bad. And so there's nothing more frustrated when you're riding a bike and you get stuck all the time at each signal. So this may be something you want to pay attention to and just see how well your traffic signals are timed for your bicycles. And you can just do that with the green band. So we're kind of running out of time, so I want to make sure we can show you this example. It's really easy to drag over these cycle tracks and just kind of position them into place. Like I said before, you had to worry about all of these extra legs and things, but now we're just kind of dragging in cycle tracks. And again, it really just depends on how close you want to get them. Whoops, there we go. And if you zoom in a little closer, you can just get them lined up the way you want them. Okay, so that's probably good enough. So you can see how fast it was to create cycle tracks compared to the last method. And now we need to make sure that these subnodes are all on the same controller. The main node is controller 13. So we just go to the subnode, and each one of these you would just change to signal 13. And now they're all on the same intersection 13. And I've already, since I copied it from the example above, I already had the phase signal group number already put in. So that matches up to the controller that I already had copied from before. So pretty cool. And also another really cool thing to note is that clearance intervals can be different on the bike phases versus the vehicle phases if you model it like this. So, I mean, bicycles, since they're going slower, they need more time to clear the intersection. So you're able to have that flexibility. All right, so I better get moving on again. I got a little excited about that. On the Boulder example, this is one of the intersections where we had a cycle track. And I'll show you actually what the Vistro export of this looks like in a few minutes. But it was the same technique I put in where I created just the simple one-way leg and just got it really close to the intersection and then tied the two controllers together. Going back to my model here, there it is. Yep, here's the cycle track. You can see it's exactly that same technique I had before. And then I follow the cycle track down. It's actually a contraflow cycle track to the vehicle lane, and there's separation. As I get into the pedestrian mall, I don't have to connect the two intersections together. I just stop the bicycle track on one side and then the vehicle on the other side, and it was real easy to code that way. And then down at the bottom of the cycle track, there's this interesting conversion because there's a driveway here. So it actually, the bicycle track ends at this driveway intersection. And then there's a short, like, I believe it's the vehicles have to turn left here, but then the bicycle could go straight. So it's very interesting there. Okay. So in summary, this is, again, all of the different urban street kind of things that are around the Pearl Street pedestrian mall. But let's see what this looks like within simulation. I mean, of course, as you know, Vistro has a great export out to Vistro, and we've made some massive improvements on that with our newest version. And so it actually creates like these really great geometries right out of the box into the Vistro model. So this is that same overall view, but on the Vistro side, you can see already we have buildings, we have our streets already generated. And for building this from scratch in Vistro, I'm not gonna lie, it would take quite a bit of time here, especially when you have to put in these signals and put in some of the details for pedestrians and code all of the geometries and things. So it's a real savings going from Vistro to Vistro in this case. And then you can see the quality of the conversion. This is actually the exclusive pedestrian phase that is there, not the leading that's in the example. But you can see the quality here. We've got, the vehicles driving in the right lanes. We have, or the correct lanes. We have the pedestrians crossing exactly on the crosswalks where they should be. And then somebody, if they wanted to model this, you could go into VisWalk, if you wanted to, and actually code the pedestrian mall in VisWalk and get a nice pedestrian simulation. And then Vistro has the parking generator now. You could code the parking and get a nice simulation of how the parking fills up and impacts traffic. It's very, very expandable, let's put it that way. This is one of the primary two-way to one-way conversions here. There's 4 of these in this model. And you can see down at the bottom, this is the two-way side, and up top, up here, at the north part, that's the one-way side going around the corner with the left turns. Here is that one part of the contraflow bicycle lane that kind of merges into that driveway. Now, I mean, this came in. I didn't really do anything. I had to change one connector, I believe. It was just going in the wrong place. But this came in out of the box, basically, into Vistro. I did have to add the bicycles to the model, but that's just an input with one route. So that's not a big deal. And here's the other part of the bicycle lane here, coming in from the north part of the model. And there was one roundabout in my study area, and this was just a straight out of the box conversion from Vistro using a simple, small one-lane roundabout. Boulder does have a bunch of these like micro roundabouts. So this tool would be really good for them, and then be able to study how the roundabouts impact with the adjacent intersections.